Good evening to one and all. Today we are going to use polynomial regression for predicting wind power plant power generation. Right. So first you got to see. First we need data sets. Already I have data. Right. First I delete the data file here. Right. Previous video lectures are I'm using what's called by using random functions and generating data sets. With the help of those data sets, I'm done some predictions, solar power generation or EV range predictions. Here we are going to do the polynomial regression for predicting wind power plant. Okay, for this case we need data sets. So data sets already I prepared. Just I want to upload data sets in Google. So Google has a feature. Here you got to see. Click over here file. In that file, click upload to session storage. Just click. So wind data sets. Okay, right. Now upload the wind data sets. Then once uploading is over, just right click, copy path. Right. So that path you have to mention over here. Okay, right. Now you are running. Right. So see, without this command, it's only run. Okay, it's not showing any result. Now just I'm putting df, that means data where it is stored. It is stored in df. So df.head it is only showing head of the five row and column data sets. You got to see 5 rows and columns. Here you got to see 0, 1, 2, 3, 4. Okay, so 5 rows. So here you got to see these are the features. What are the features? 1, 2, 3, 4, 5, 6 features are exists in the data sets, followed by wind power output. It is a target variable. So these are all decides what is output. Here wind power output, how it is going to vary based on this all the parameters, right? Okay, this with help of these data sets we are going to run the our model and we are going to try to predict. Okay, right? So if you want charts or anything, if you want, you can make it here, right? Come back to the program. Okay, what is the first step? First step is we should import all the necessary libraries which is belongs to your program. So first of all, NumPy library, then first is here it's a NumPy library, then pandas. Already we have an experience is 2 and 3 matplotlib library. Okay, these 3 are basic essential library. Whenever doing machine learning program, we should upload it. Okay, default, then followed by cbond as SNS. Okay, cbond is what is the purpose? It is used to what's called a statistical plot. Okay, for the purpose here it is used to generate a heat maps. Okay, here it is used to generate heat maps. Heat maps I'll show you. At the moment you can easily identify what is the purpose of heat map. Okay, now come back next. Machine learning model as usual. Here we are doing what's called polynomial regression. So that I'm here model I selected as a pre-processing model from sklearn machine learning library. Right. In that I'm importing polynomial features one class followed by standard scalar one feature as a class. These two classes which is used to develop a model for polynomial regression. Okay, followed by model underscore what's called this is our model. Okay, what purpose this is? It is used to import train test split. Already we know what is the purpose of train test split the data sets. Okay, then followed by linear underscore model, and here I'm importing linear regression model here. Okay, which is used to train the regression model. Then come back to the what's called metrics. Here I'm selecting 3 metrics. What's called mean absolute error, mean square error, and R square error. Right? Okay, these are the what's called basic library, fundamental library, followed by machine learning libraries are uploaded over here. Okay, this is the first step. Just I want to run. Yeah, it's running. There is no error. Then I'm going to upload the data sets here once again. Okay, so to upload the data sets, we need file path. Already I gave. Okay, once again I'm going to here. If you want run means once again copy file path. No need 2 times running, but anyhow, so future purpose I'm doing this is okay. So it should be within double quotation, otherwise if it's a error. Okay, right? Okay, fine, no problem. Come to first, I want to find the correlation between the variable. Okay, right? So for this case, I'm going to generate a heat map to visualize a feature correlation. For this case, I decide the figure size is 10 plus 6. Okay, it is representing figure size of the figure, total size of the figure. Then followed by heat map annotations need. Okay, whether it is what is annotation, is true or false, whether what is the correlation between these two. Okay, that is we need. For this case, this command is used. Okay, then followed by its title. This is used to show the flat. I'm running, then I come back once again. Here you got to see what are the things are available here. See, this is a future correlation heat map. Okay, right? So here also wind speed, wind direction, air density, temperature, humidity, pressure, and wind power output. So what is the uniqueness of this kind of flat, which is used to show the correlation between the adjacent variable. Okay, for example, we take wind speed, wind power output. The correlation is 0.85, whereas wind power output followed by air density output is 0. Okay, at the same time, wind direction and pressure output is how it is, what is the direct correlation is 0.03. Okay, so like that we can find each every parameter correlation. From this table we can easily identify and compare to all other parameter. Highly influencing parameter is wind speed only. Wind speed, already we know wind power plant output is directly proportional to wind speed. Okay, right? But anyhow, cutting speed, cutoff speed, everything is there, but we don't want to consider here. So heat map is which is used to show the correlation between the adjacent variable, which is decide the output. Okay, now come back here. This shows a correlation. This annotation is there. This is the representative for that purpose only. Okay, then followed by cool warm, the color is it is. Then this value 0.2 f, right? Okay, then come back. Now, first step is we have to fix future and target variable. Okay, for future we can mention all the future name, otherwise we can drop last column of future, that becomes target variable. Okay, so here we go to the what's called data set. This is the last column, it is belongs to what's called target, remaining are future. So that one command is there, instead of mentioning all the column, df dot drop. Okay, so columns, which is a column, in that column we should mention what we want to drop. Okay, within the square bracket, right? Okay, it is used to drop the target column. So why? Because of target output is going to vary based on the input. So for this case only, followed by y is equal to df, data frame once again we call. Okay, in that we need only this is. Okay, why? Because it is only one target variable and compared to previous one. Understand, right? Now I run. Okay, so after running I want to print x, okay, cap x, running. See, so last column is missing here. We'll come to print y. See, where is the y? This is only, okay, only target variable, right? Understand what is the purpose? Just we assign input and what's called futures in x, target is y. Okay, then what is the next step? Next step is we should immediately split the data into training and testing. So as usual we know, so we are training 80% data for training and 20% data which is used for testing. Okay, it is over. Then we create on functions to evaluate the polynomial regression for different degrees. Okay, so based on the polynomial degree, the output is vary. Okay, so that we are for identifying that purpose only here I'm doing small, I'm creating a small function here. Okay, so the function name is polynomial underscore regression. Here within the bracket I mentioned degree. Okay, right? Then we should to transfer what's called a polynomial feature into what's called one variable. Okay, so here I'm creating one degree. So assign the value degree is equal to degree, you call data. So some other place degree I mentioned, what are the things you got to see about the function. Degrees comes from 1 2 3 4 5, okay, right? 1 2 3 4 5. Then see, we can consider 5 degree here, okay, 5 degrees here, over here. So come to here, so we are creating one variable. Degree is equal to degree right now, okay. Then we have to transfer the data, okay. Just we are pass, we fix the future of degree, okay. Then followed by, we should transfer the data to the polynomial, that function, okay. Why? Because of here the polynomial here is it's objective. This objective has this complete polynomial future with the degree, okay. Then bit underscore transfer function, which is used to transfer the data to the what's called our variable. Here variable I'm created is x train, y train, okay. X train underscore x underscore train poly, which is used to store the values, okay. Here which value it is storing? It is storing what's called this polynomial data, okay. Poly is objective, sorry, it's an object. It is already has a polynomial feature, okay, with the degree. So those degree, we fit underscore transfer function, which is used to transfer the data. Then followed by, we are doing here testing the data. Why these two functions is needed? The two functions are play major role. One is, first one thing, it is used to expand the futures by creating polynomial terms. It may be squared or cube or intersections, okay. So bit underscore transform function, let us see bit underscore transform function, and within the bracket x train is there, okay. So bit, what is the purpose? It is learn how to generate polynomial feature from x train, okay. The fit function is which is used to learn how to generate polynomial features from x train, while following by transform applies the transformation generating new features, okay. So fit is learning and transfer function is generating new features, okay, right? This is a very important critical point here. Then followed by, we are using standardized scalar, okay. Standardized is why needed? It is used to prevent issues caused by large feature values which is dominating the model, okay. So that with the help of standardized feature, we standardize the features, okay. So for this case also, we need two what's called two functions, two stage. One is x underscore train underscore poly, okay. Then in that scalar already we have standard scalar functions. Just we are transferring the x train poly underscore variable here. Then followed by one more variable here. What is this two? This two belongs to here only. Already it has polynomial features degree followed by the transformed input for training as well as transformed input for testing, okay, right. Then we go for model. So train polynomial regression model. For this case, model one object created. So in other word, one variable created to store the linear regression, what's called model here, okay, machine learning model here. So in that we are just to pass the fit the data. What are the data? X underscore train poly, y underscore train, okay. These two data sets are we are transferred here, okay. So here you can see with the power output only here. Here x time we have lot of features, so that it's not showing, okay. Come to here. Then here we are going to make a predictions. For prediction, y underscore predict the variable, which is has a model already here developed model, sir, model data, okay. So model here is there, that model data predict, we are going to predict what we are going to predict, x test underscore poly tested data, okay. From original data, we have some data we already splitted for testing the algorithm. Those data which is used to predict the model, okay. With the help of that model, it is going to make a predictions, okay. Then evaluate the model. We have to evaluate the model based on the metrics. Here we are using three metrics as it is: mean absolute error, mean square error, r square error, okay. Between two what's called test and predictions, okay. Between test and predictions, right. Then it is used to print the all the metrics, okay. We print the all the metrics, right. Then followed by we should know what is the which feature is more on our output. For this case here on future underscore name on variable we have created, then poly already we have that model. In that by using this key we can get the futures or the futures. So futures where it is there, it is from X data, in that only columns. Okay, those data we are taken here, right? Okay, it is used to get the future name only, then followed by using np dot absolute, we are going to find the coefficients of absolute coefficient values. Okay, then we make a data frame with the help of this command. Okay, then come back, start what is importance of each feature. Okay, so already why I'm here, I'm not interested to give too much explanation. Why? Because of Heatmap already we gave clear cut instruction, but anyhow one more method is there which is used to shows importance of features, for this case only here. Okay, then come back, plot top, top 10 important features here. It is used to based on, actually we are taken here I hope 6 to 7 features. So among which is top, which is contributing more your output, that is for that purpose we are making these plot functions. Okay, then return is r score error. This function is that we are creating, that function is creating r score error as a return. So come back here, once again I go to the complete program. So define followed by, here we are on function we created define. So variable polynomial underscore regression, here degree we should to identify the degree, then we pass the value here. Okay, first address it may be 1, second 2, third 3, 4, like 5, like that it's going to vary. Okay, then come back to here, then we are transferred data to the polynomial features, then we standardize the data. Okay, here you got to see, just we transfer data to the polynomial, then transfer data to the polynomial. Okay, so here only fit underscore transform. Why? Because of any machine learning algorithm need to training, for the case only fit underscore transform we are using. Here no need, already algorithms already trained, so that here using x underscore test. Okay, the standard feature is which you used to standardize the feature, so within the limit. For this case here using standard scalar functions. Okay, so come back here, why need standard scalar function? Here we see you see it is a 2-digit, the 3-digit data, then followed by here you got to see 1 point something is there, then power generation is 4-digit. Okay, so if to improve the accuracy of prediction we should do the standardize the all the values, so that we are using here standardized scalar functions. Then followed by we are trained the polynomial regression model with the help of this two code. Okay, then make a predictions. Once prediction is over, we are going to evaluate what is what is called uh, quality of prediction or others efficiency of predictions. Okay, with the help of 3 metrics we are taken here, it is used to print the value, then followed by what is importance of future, then what is the first 10 important features are displayed with the help of that, then it is written is r score. Okay, then already I told you we are selected here 5 degrees. So 5 degrees we make as a list for future use. Then r score we make a create a on list. So all r score should be put over here. Okay. So just we have to append the data with the help of here. Then come back next one thing. Each and every degrees how r score going to vary, to identify that this loop is using. See, append polynomial underscore regression. Here d is a variable. What is the degree is passing? First degree, second degree, third degree. So once it is passing, what is the r score? How is vary? So all the things are appended with this for loop functions. Then we this is our nothing but it is only for plot the figure. Okay, just for plot the figure first one thing figure size, then followed by it is taken degree, r score. Okay, two variable, then mark style is one is o, another one is what's called I think orange, another one is that line style is dot line, color is blue. Okay, these three things are used. Then x label, y label name, followed by title, grid is enabled, need to or not, otherwise show the things. Okay, just run the things. Now running, see how many outputs we got. Okay, then how why it was coming. First you got to see degree 1, at that time mean absolute error, mean score error. Okay, then followed by Importance of top 10 futures. Okay, so top 10 futures you got to see. Wind speed, absolutely it is correlating more, while it is impact of output. Okay, wind speed is high, automatically output is directly proportional, followed by air pressure also somewhat influencing wind directions also. Then temperature somewhat influencing. Why? Because of temperature variation only output is going to vary. Then humidity impact is very less, negligible and compared to what's called wind speed. Okay, come to the degree 2. So while we apply degree 2, at the moment we got to 0.856 R square error. Remaining three values are you take it. Now I consider R square error more and compared to others. See, R square error is 0.856 say. Okay, here you got to come R square is 0.741. At the same time, the importance of future also going to vary once you are increasing R square thing. Okay. So what is indicating that when degrees 2, at the moment majority of the factors are influencing output of the what's called wind power generation. Okay, right? Then you come to here. So degree is 3, at the moment 8.35. That means R square is it is prediction efficiency is reducing. So similar patients we can see here also. Okay, when degree is 4, at the moment R square is you got to see 0.649. Okay, right? So overall comparative analysis, we found that when degrees C, R square is what's called polynomial is 1. At the moment R square is here only. Okay, what's called very near below. Okay, then 2 somewhat improving. 3, it is once again dropping. Okay, so this is the best degree to predict the what's called our wind power generation. Okay, so it is what's called okay. So from the above 20 minutes 25 minutes, let's say what you can understand by using polynomial regression, how to forecasting wind power generation. Okay, at the same time, how it is what's called degree of polynomial degree, how it is impact on our predictions. Okay, so if you have fixed a degree 1 is slow, accuracy is low and compared to 2. So 2 and compared to 3 and 4, 2 is when degree is 2, the developed models perform well. Okay, at the same time, all the degrees level, wind speed is a direct relationship with the output power generation. Okay, I hope you will understand. If you not understand which part you are not understanding, you got to feed the information through command window. I will give brief information about all the things. So time constraint, I just run. I will show some part what are the things are very important regarding to the to predict wind power generation. Those information only I am shown here. The remaining lot of information is there regarding to this program. If anyone interested, you can comment with me. So I will explain for the particular person and separate either through online or offline. Okay. Thank you. We will meet in next lecture.